There's a nice connection and flow to these things, and that kind of brings us to the final speaker of our morning session. And I'm pleased to introduce Dr. Nick Lapointe, who is the Canadian Wildlife Federation senior conservation biologist focusing on freshwater ecology. Nick completed his doctorate in fisheries science at Virginia Tech, and his research has focused on the highest threats to freshwater biodiversity, including invasive species and habitat loss and alteration. In addition to Nick's applied research, he also engages in policy advocacy, stewardship, outreach, and other actions to strategically conserve Canada's freshwater biodiversity and inform conservation and management decisions. In his spare time, Nick is an avid outdoorsman, spending his free time hunting, fishing, gathering, and gardening according to the season. Nick, it's great to see you again and have you with us today, and I'll turn the mic over to you.
Thanks, Jason. Thank you for the invite, and my appreciation also to Pete in covering some of the connections between freshwater connectivity and resiliency. I looked at the agenda and realized my talk is the only one without the word resiliency in the title, but that's okay. Those connections are clear. My talk is branded here, Canadian Wildlife Federation. For those of you in the US, we're a large NGO in Canada, similar but unaffiliated with your National Wildlife Federation, for instance. Despite that branding, I want to recognize that the work that we're presenting here really does represent a collaboration between our efforts and partners. Many of those partners, including PSF and Jason himself, have been instrumental in the thinking and the development of the processes and tools that we've developed here, and that I'm presenting sort of on behalf of that broader collaboration. Other important partners include the province of British Columbia's Fish Passage Technical Working Group, especially Craig Mount and their colleague at Hillcrest Geographic, Simon Norris, who pioneered a number of the models that we're using here and helped us refine them and develop them into the tools that are seen here. And many of our Indigenous partners in specific watersheds where we've applied this work, and I'll give a case study as one of those. So really, this is not just Canadian Wildlife Federation's work by any means. This is really a collaborative effort. And so, I'll talk about our connectivity planning approach as sort of a practical prioritization exercise to identify sites to take management action on. And really at this stage, what I'm presenting is focused on that longitudinal connectivity element. There are certainly efforts underway to develop similar systems for lateral connectivity, but they're not as advanced. And this is a process that we've now applied at 11 watersheds across Canada, including 7 in BC, some of which we lead, but we're really shifting towards supporting our local partners, whether those are Indigenous organizations or community groups that are looking to restore connectivity in their watersheds. They're really best suited to do the implementation and decision-making, and we can provide with the sort of science and mapping and modeling support. And so we were faced with this example. Here's the Horsefly River watershed. So this is a tributary to the Quesnel River, which is a tributary to the Fraser River, about 700 kilometers upstream of the mouth of the Fraser. And it hosts sockeye, chinook, and coho salmon. And this is an area that the province had done a lot of barrier assessment work. They had assessed about 700 of these potential barriers before we started this work. And one of the challenges is that assessing 2,500 barriers is about $1 million in field assessment without considering assessing the habitat that goes along with them. And, could take many years. By the time you're done that process, some of the earlier assessed barriers may have degraded, or crossings, let's say, may have degraded and become barriers in that time anyway. So we wanted to figure out how to get out of that loop and prioritize these many potential barriers on the landscape. And so, part of this is to put this connectivity restoration planning within the broader conservation planning framework, and to think about this as a thematic plan that really focuses on these localized barriers to fish movement, primarily the longitudinal ones, the culverts and dams, but also with consideration for lateral barriers and the other types of barriers to fish movement. It's not intended to be an overall watershed plan, but that that is really the broader context I think is needed to be able to recover salmon. To think about connectivity as one element, and our previous speakers have explained this very well. And ideally, it serves as an example of ways that you can quantify, prioritize, and understand the watershed and where the problems lie, and where to put your efforts. In the absence of that broader plan, so this would work well in a broader plan. In the absence of that, one thing that you can do with just focusing on connectivity is you can account for some of those other threats. So you can avoid prioritizing barriers in tributaries that are so degraded where restoring salmon access alone is not going to result in benefits. And so that can be a sort of a future area, and you ignore the longitudinal barriers there. You can also think about where the returns on addressing an individual barrier are going to be lower, and where you might want to stop focusing on barriers and start focusing on riparian zones or other components. And the one thing we found with these, as long as we continue advancing these plans on an annual basis, is these really help address one of our funding gaps, which is when you have a barrier that you want to get funding for to restore, one of the questions is, why is this barrier important? And what is its context in the broader landscape? So, these plans have a defined geographic area. They pick particular focal species or guilds that you're mapping connectivity for. You're estimating how much of the habitat for that species is currently connected, with uncertainty. Based on that, you can develop these SMART goals that you basically say, if this is your current status, what is your desired future status? And that allows you then to prioritize barriers and develop action plans to meet those goals. So one of the things that we did, and this is taking that thinking and previous work from the province, is we can rule out parts of this watershed where naturally salmon would not have been able to reach in the first place. And we've done this not based on, distribution maps, which, may suffer from shifting baseline knowledge of where salmon once were, but we do this based on the natural barriers. I believe there's a falls here that cuts off a lot of access to the rest of the watershed for salmon, and historically always would have, for instance. So we've restricted the area of interest to the areas that potentially salmon would have been able to reach in the absence of human barriers. And so this already brings us down to only 530 barriers of those 2,500 to consider. So that helps with that triage. We then recognize that within that accessible area, there's only a subset of habitats that salmon might use for spawning or rearing. And those can be predicted based on an intrinsic potential modeling approach, sort of based on their gradient and channel width or discharge. But they can be added to by using observation databases. In this case, we use the Pacific Salmon Explorer map of known spawning habitats to add to anything that the model missed. And then we took these models and shared them in workshops with local knowledge holders to adjust and correct areas where we've mapped areas to be unusable or inaccessible to salmon, but local people know that they are used or usable, as well as local monitoring reports, data sets, and so on. So that's sort of where some of the legwork comes in. And the reason we're doing this is that if you're going to prioritize a barrier here, you don't want to count all of this sort of corridor habitat, essentially, that isn't going to serve a great purpose in spawning or rearing. Really, it's just these smaller areas at the end, and prioritize that over this area where there's more potential usable habitat for those salmon. And so this reduced the number of barriers to consider to 109. So again, much lower. We were then able to overlay some of that existing assessment data, as well as local knowledge. Part of that local knowledge review was identifying, other natural barriers like waterfalls or unmapped anthropogenic barriers. And through that exercise, we were further able to reduce the list of known barriers that have been assessed and modeled or mapped structures that have not yet been assessed that may or may not be barriers. But for the time being, we'll treat them all as barriers to 77. So already quite a bit of triage. And this gave us an initial, back in 2021, connectivity status estimate of 81%. And this is 81% of the usable spawning or rearing habitat for those three species of salmon combined. how much of that was downstream of any known barriers versus upstream of a confirmed or potential barrier. And so having that allows us to set, an initial goal. And this is a goal that we expected would be refined as we improve knowledge of the system. We sort of said, okay, great. If we're at 81% now, we'd like to get to 91% within 20 years, which could require reconnecting 57 kilometers of habitat. Not a particularly ambitious goal compared to some of the progress that's being made in the US, but in Canada, the amount of funding that's been available for barrier removal, that's potentially a more realistic timeline. And then, some of you may have seen review papers by McKay. There have been so many different GIS models developed on how to prioritize barriers and optimize and rank barriers and so on. We wanted to sort of have, draw on those and come up with a practical way of thinking about, either individual barriers or situations where addressing 2, 3, 4, or 5 barriers in combination would give you a better per barrier gain. But what I want to highlight here is that this is not a prioritization for removal. This is a prioritization for assessment. We want to focus our assessment work on the potential barriers that have the greatest habitat gains upstream, because if they're confirmed, those will be among the most important. If they're not barriers, they're going to have the biggest effect on the uncertainty in our model, and will really help to narrow down what we know about the system. Those barriers with a very small amount of habitat upstream just are not priorities for either assessment or potentially for removal. And then we develop an action plan typical of any conservation plan. I won't focus on that today. What I will say is that of our field assessments that we did in 2021, 2022, that reduced the number of barriers to 51. So we were able to exclude a number of barriers. 16 of those were confirmed, and 35 still need assessment. Many of these have been assessed this summer, so we'll be able to revise this sooner once we have those results. But what we've developed in more recent years is what I like to call a habitat accumulation curve, a nod to Paul Angermeyer's species accumulation curves. And what this is showing is, those sets of barriers or individual barriers, sort of the amount of habitat upstream of each. And this visual is really informative in goal setting. There really is no right answer as to where you stop removing barriers, but it is pretty clear that when you get up into this area, spending $500,000 per barrier to get, a 100-meter habitat gain, unless that's, a thermal refuge or some particularly critical habitat, may not be where you want to be investing your restoration dollars. So this sort of helps us to understand, and gets refined over time through that assessment work, how much of the disconnected habitat you could restore by addressing 5 barriers, 17 barriers, 20 barriers, or so on. And so over time, our initial estimate of the amount of habitat in the system decreased, because we found, sometimes we would find a natural waterfall and we'd realize that there's less habitat in the system than predicted. We also looked at some of those model barriers and found out they were passable or were fords or did not exist. And so the system itself is more connected. And so, we've already met our goal without removing any barriers, but that allows us to then say, okay, now that we know the system better, what's our revised goal and how many kilometers of access would that take? And even looking at those 16 barriers that have been confirmed, we were able to rule out 3 of those because the amount and quality of habitat upstream was really so marginal that the investment in those barriers, those are ones we can leave until their end of life cycle and, contemplate replacing them with a more passable structure at that point, or something that's cost effective that may not be passable because the gains are not that relevant. So really this gives us 13 barriers that we've prioritized for fixed passage restoration, but we're not really prioritizing among those. And I'll explain why in a little bit. And so our assumption as a conservation organization was we would identify these priorities, we would seek funding, we would remove those, and we started in 2023 on Bosker Lake Creek Road. This was a Forest Service road with a culvert there, had the funding to replace it with a bridge, and in exploring that, we spoke with the road managers, realized the road was redundant, and we were actually able to decommission it for about a third of the price, better ecological outcomes, a number of funders there that help support that. And to date, that's the only one that CWF has led. It's turned out that we've looked at who owns these barriers, because we're not approaching this from, a one agency or one owner type perspective. And 4 of those 13 are owned by the Provincial Ministry of Transportation. They've already developed designs for a couple of them, and they're considering designs for the 2 others that they own. So there's progress being made there. Initially, that was rapid. It's slowed down a little bit, so we'll need to continue pushing on those. At a meeting between one of our staff, Betty Rebellato, at a Horsefly River Salmon Festival, she connected with Tolko Forestry Company's environmental rep, and through their joint conversation, they realized that Tolko sort of has a responsibility to do maintenance of Forest Service roads when they're out on their cut blocks, and that includes areas that aren't owned by them or on their blocks themselves. But they have their equipment mobilized, and so they can replace a Forest Service road culvert with a bridge for under $100,000 when that might be a $200,000 to $300,000 project for us. And what's even better is that because this is a fishery-sensitive watershed, there are mechanisms by which they can recover any costs that they spend on ecological restoration of fish habitat. They can recoup those by reducing their stumpage fees that they pay to the province. So they've already right away went and addressed 2 crossings. I believe they did another this summer, but I don't have that confirmation yet, so I didn't put it up here. And they did that at no cost to their own bottom line. So that was just an excellent solution there. And then, of course, some of those remaining barriers, we could look at going the enforcement route or public campaign. So far, that hasn't been necessary, but if there's a really challenging one, that's something that could be considered. And so overall, of those original insurmountable list of 2,500 potential barriers, we have identified so far 13 of those as priorities, and 3 have been removed and 6 are progressing. So this is it's not quite if you build it, they will come, but if you identify them, they will come. We've had a similar success in PEI, for instance, where after working with us on a couple of years, a provincial road manager said, well, let us know what your top 10 priorities are, and we'll address those in the next 5 years. So that's been great. I will say, of course, these are the barriers to salmon. Some of these 2,500 would be barriers to other fish species, such as rainbow trout, and that is a different issue, and the list would be higher. But I still think this is a valuable example of success. So some of the things we've learned is that, it really is important to consider all those barrier types simultaneously. I think most people do this, but there are examples of, Ministry of Transport or Transport Department structures that focus only on prioritizing their structures without thinking about whether there are dams or rail crossings upstream. You really can't, prioritize or address one barrier type without thinking of those other types. You really have to think like a fish. Our models are really useful, but they can be applied anywhere in the province. I'll touch on that in a minute. But without taking that time to look at the model outputs with local knowledge holders and refine them and manually tweak those outputs, you really miss a lot of the context and can save yourself a lot of time in field assessment by incorporating that local knowledge, whether that's traditional knowledge, resource manager knowledge, existing reports, or so on. There is a manual step that does need to be done there. As I said before, what we think of this as is prioritizing for field assessment. And it's way easier to understand the system if you have to go out and assess 100 likely important barriers than a few thousand. And you can really get much more quickly to a point where you have an action plan in place by doing that. And, the point that I was making on the previous slide is it's not so much about prioritizing among those 13. It's just identifying those 13 as important and then figuring out what is the best way to address each of them. There's a lot of talk out there about optimization models, prioritization, of barriers relative to each other. And that's really not useful unless you're talking about a set of barriers that you own or have power to restore, and you have a budget in hand and you're trying to figure out how best to allocate that budget. That's not the situation we're in. So this approach has been much more useful. And so, just something I want to say to the folks that are on the call is that these models that we've built are in an open source database called BC Fifth Pass. They're available for all of the salmon watersheds in BC and can be applied right away. They're accessible through APIs, so they can link into existing other spatial tools and online frameworks. So this isn't something that lives on a CWF laptop. Those models can be run right now and can give you a connectivity status estimate for any watershed. But there's so much that can be achieved through, we've worked out to be like 5 to 10K in staff time to just at a watershed scale, review the imagery for some of those modeled structures, incorporate those local data sets that already exist, and then go over those refined outputs with local knowledge holders and make edits to it. That is really worth doing before actually going out into the field to assess structures. And, through that process, you can have your connectivity status estimate, you can have priorities for assessment. And if you've already done a lot of that assessment work already, but you're struggling to put that into context, well, this will clarify sort of how important the known barriers that you've identified are relative to other ones that have been identified or potential structures that have not yet been assessed. And so that really helps to create that context for funding and for why a known barrier needs to be addressed. And that's my last slide. So thank you, everyone. I look forward to questions.
Well, Nick, thank you for that talk. I have lots I'd like to say about it. Again, like the other speakers, I'd enjoy having just a conversation with you, but I'm going to turn to the Slido right away to try to get as many of these questions in as we can. This first one's been floating at the top for a bit. How much overlap was there between local knowledge and the model you used to prioritize areas? Besides adding areas to consider, was there ever conflict between the areas prioritized by local knowledge and those by the model, and how did you handle that?
Yeah, well, I wouldn't use the word conflict because I think the two have been very complementary. We chose to take a very generous modeling approach, knowing that we would overestimate sort of usable habitat because we didn't want to miss anything that would be worth assessing in the field. And so because of that, it was rare that the models missed known habitat. There was one example of all our watersheds is in the horsefly, where a local consultant identified a few known spawning and rearing habitats that we just added those segments to the model. And there have been a number of cases where we've worked, I remember a consultant in the Quesnel watershed talking about a particular tributary and saying, oh, there's a point in that tributary where the gradient increases and salmon don't get past. And then we saw that was where the model ended. And okay, great. That helped him to sort of trust the model a little bit. But the value of local knowledge has been in identifying some of those unmapped natural barriers like a waterfall that fish couldn't get past. There's dams, for instance, sometimes that are mapped that are not mapped, that are known, that can be added in. And so I would say the local knowledge contribution in our exercise of looking at each tributary and going through where the habitat and barriers were mapped and refining that with corrections to the model has been as valuable an exercise as the modeling exercise. So I see the two as complementary. To me, the model kind of helps to cover that. Where might salmon be if they've been extirpated for 100 years and people have forgotten that they were once there? So that's really where its value comes in. The other reason that there has been a conflict is that we don't really focus on habitat quality. And at this point, it's been presence absence. And so it's not so much about important habitat as really just distinguishing, usable for spawning and rearing from the movement corridors. And that comes in more when you get to those, say, 13 barriers that have been confirmed with habitat upstream, a more qualitative interpretation of the quality of that habitat. And that's where local knowledge and the field assessment work is going to be more valuable than our rough models that simply tell us where to go and do that field assessment work.
Well, I think that the thread of your answer actually connects to the next question on the list, and it ties back to Pete's presentation on the genetic flexibility of salmon, and asking about whether you're worried that restricting the assessment to streams that were previously accessible to salmon might result in missing opportunities that would really benefit salmon, as an example, opening new or previously unused habitat.
Yeah. I think as a conservation organization, there is this concept of habitat enhancement and a history of habitat management where people have, dynamited waterfalls or put fish ladders around waterfalls. And as a national organization, that's not something that we're necessarily going to lead. There are potential consequences of competition between salmon in those new habitat and the resident species that exist there. That would be something for local people to decide if they want to work to favor salmon over other species in their local waters. And so it's not something we necessarily oppose, but it's not something we've incorporated. And I think there's ways to support local partners who want to use this approach to contemplate, added access to historic habitat into this modeling framework. That would take a little bit more effort, but we can, add parameters and add considerations to these models if that's where local people are interested in taking their habitat management.
Well, Nick, I'm puzzled by that. Like you're saying, there's other things out there to think about besides salmon.
There certainly are, and we haven't had the funding to do that, so I don't have a rainbow trout model to show you right now.
Well, I'll pull at least one more question off the Slido list. This next one goes to funding, and I know you touched on it in your talk, but maybe the questions around dwindling funding for fish passage projects. Who do you see funding the assessment and restoration work in the future, or should we be looking at lobbying to restore funding from government sources? And I'll just kind of give you some free range to comment on that thread of question, building on what you spoke to in your talk.
Well, you could talk about a tale of two jurisdictions when you compare BC and Washington State, for instance, when the technical working group has addressed, I think, around 200 barriers in 15 to 20 years. And you look at Washington State and on the Forest Service roads, their Family Forest and Fish program, I think the number's over 9,000. And through the tribal injunction, the state highways, I think that's about 400 barriers that have been addressed with $4 billion in funding through a gas tax levy. So the amount of barrier removal that's happened in Washington State with those funding mechanisms compared to BC without them point a straight line towards the need for funding and not less than what we've had in the past years, but far, far more. How we're going to get there, whether that's lobbying or lawsuits, or public campaigns remains to be seen, but there's a definite need in Canada to match what's happening in the U.S.
Nick, I'm just going to ask you something because I know a bit about this, and if you're comfortable, just before we move from the session or the segment with you to the open session, I know that you touched on this in the opening of your talk, you're also thinking about lateral connectivity. And like maybe in a minute or less, do you want to just enlighten the room here in terms of what you're thinking and what you're working on as another thread to the work you're doing in this regard?
Sure. I mean, I think my goal would be to be able to replicate that same process to say how much lateral habitat, is there or was there in the system, how much of it is currently connected, and where are the patches that are disconnected. But that is not nearly as simple as looking at, the lines of streams. And so we've done things, we've tried modeling floodplains, we've tried drone surveys and helicopter surveys with people who are experts. And so at this point, we're just sort of trying to figure out how can we map those lateral habitat features. And that's sort of the state that we're at. There isn't the same body of literature in, clearly mapping and prioritizing those habitats as there is on the longitudinal side. So I think we're not the only ones who are behind on that, but we're also not the only ones that are working at it. So lots of others are attempting those same things, and it would be great to converge and find sort of practical ways of implementing that at watershed or regional scales.
That's great. That's a really nicely packaged answer. And I wanted to ask that because I thought, it connected to the talks that we've had earlier this morning and maybe sets us up nicely for our morning panel session. So I think now I'll give the other panelists a heads up that we're going to call you back. And the tech team here at Oboy are going to get us set up for that. And Laura and I have been kind of keeping some notes on the side, during the morning talks. And now would be a time, I think our our support team in the background are going to be looking to pull questions that we've had from this morning that we didn't get to. But also, if you want to put a question in, even if it's one you've posed before but we didn't get to it, or if you have a new version of that question, now that you've heard all of the talks from this morning that you want to put to us, we'll be turning to those. Yeah, if the OBOI team can bring our panelists up, we'll get going with that panel session.